Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate at a different amusement park, a Ferris wheel was designed so that half the wheel is actually below the ground. Now that sounds pretty cool. And maybe some of you are like, that's weird, Stevenson. I don't know about that. But maybe it goes underground and there's like really cool like black light stuff or cool shadows or I don't know, holograms or some cool technology stuff down there to make it look really neat. Regardless, what we now know is this is ground level. And we know our Ferris wheel goes partway underground. The diameter of the Ferris wheel is still 50 feet. Okay, so let's draw that. The diameter is still 50 feet. The top of the ride reaches 25 feet above ground and 25 feet below ground. So what that tells us is half of the circle is above, half of the circle is below, and half of 50 is 25. Okay. Riders board the car at ground level to the right, so this is where they load, and it still moves in that counterclockwise direction. So just like last time, we're going to kind of go through this about 2 full rotations. We're going to document some data, and then we're going to come up with a graph. Let's start at the beginning. At 0 rotations, how high is our rider above the ground? Well, it's 0, right? They're at the ground level there. They're not doing anything. Okay. Now, if they go 1/4 of the rotation, now the rider is up here. Well, how tall is that? Well, that's half the diameter, which is 25 feet. Let's go half a rotation. So half a rotation, that means the rider is over here. Now, if the rider's in the car at this point here, how high is the rider above the ground? Well, that would be 0 feet because we would assume it's at ground level, right? Based on how the description is. Now let's go 3/4 of a rotation. So that would be 1, 2, 3/4 of a rotation. Oh, now the rider is down here. What is that distance? It's height above ground, right? So we know that's 25, but we're going to actually write -25. Now you might be thinking, Stevenson, that makes no sense. You can't have feet that's negative. In this context, though, what does the negative represent? The negative represents the fact that the person is below ground level, a distance of 25 feet. 1 full rotation puts the rider back at ground level, 0 feet. So that's 1 full rotation. Let's do one more. If you recognize the pattern, so I'm just going to go through each one now, and I'm going to put the new values. Okay, so hopefully you recognize that as the rider keeps going around, they're going to hit these distances of 0, 25, 0, 25 feet below ground. We're illustrating that with negative and back to 0. So let's take this data and let's create a graph. Now you might notice I adjusted my y-axis this time. My x-axis is still the same. I still broke it up by quarters to match my input values here. At 0 rotations, the rider is at ground level, so it's 0 feet above the ground. At 1/4 of a rotation, the rider is 25 feet above. All right, so we have to approximate again. 10, 25 is about there. At 3/4, at 1/2, the rider's back at ground level. At 3/4, so right here, the rider is below the ground at 25 feet. And then back at 1 rotation. Okay, I'm going to graph the rest, and you probably already noticed the pattern. So I'm just going to use the pattern here. Now we're going to sketch our curve. Now again, when you sketch your curve, don't connect it with line segments. These are continuous functions. It actually is a curved behavior here. Now do you see, again, this is periodic behavior. Do you see how the graph repeats itself? So let's go through our vocabulary. So this is a periodic function because the graph repeats itself. There is periodic behavior. So let's go through the first one. What's the period? The period is the amount of time it takes for the graph to repeat itself. So you look at the x-axis. So if we start here, we go around, we come back, boom. Then we go around, we come back, boom. So you can see in this graph here, 1 rotation of the Ferris wheel is our period. Look at our midline. Now remember, the midline is the average between the maximums and the minimums. So the maximum value is 25. The minimum is negative 25. So if we do 25 plus negative 25 and we divide that by 2, we get 0. That means the midline is the horizontal line y equals 0. Well, that's the x-axis. It's the midline. So that divides the graph equally above and below. Last but not least, we have amplitude. Now remember, amplitude is the distance from your midline to the extremas, so the highest and lowest points. So let's look right here. So what is this distance? If the midline's at 0 and this is 25, then we know this is 25. Let's look at the minimum. This is 0, that lowest is negative 25. You know, again, it is 25. When you do amplitude, the fact that this is negative is irrelevant. You do the absolute value of the distance.